Today we're going to talk about the last piece of statistics, which is our z-score and a normal curve. So the first example that we are given is the ages of dogs in year available for adoption at Fairfax County Shelter last week. So these are all the data points. So we're going to represent them on this curve. The pieces of information that we need are the mean, which in this case is 4, and that the standard deviation, and in this case is 2. So on this side is my positive side, this side is my negative side, just like if it was on a regular graph. In the middle is my mean. This symbol means mean. So my mean in this case was 4. All right, so we need to add whatever our standard deviation is 3 times, or subtract on this side. So let's go up first. So it says we need to add 2. So we're going to add 2 to this, which gives me 6. Then we're going to add 2 again. That makes 8. Then we're going to add 2 again. That makes 10. On this side, we're going to subtract. So we're going to subtract 2, which gives me 2. Then we subtract 2, which gives me 0. Then we subtract 2, which gives me negative 2. So then the question is, how many standard deviations away from the mean is the dog that is 7 years old? So 7 would be right in the middle. So that would be 1 standard deviation and then halfway to the second one. So 1.5 or 1.5. That's just my guess. We can find this a much better way than just guessing. The formula that we need to use is this. So this stands for my z-score. This is my data point, or my element, it is sometimes called. This u, it means my mean, or the average, and this circle with a line over it is standard deviation. All right. So we have some of this information to figure out the legitimate answer to this question. So my x, my data point or element, is 7. My m, or my u, or my mean, we knew was 4. And then we know our standard deviation is 2. So I'm going to plug in all of this information. So let's see, 7 minus whatever this is, which is 4, divided by standard deviation, which in this case is 2. When I put this in my calculator, it gives me 1.5, which just happens to be the answer I guessed, so I was correct. So now let's do a little bit more practice using this formula. All right, so this is my data point, so this is equal to x, so I'll plug that in, 4.5, minus my mean, which we know from over here was 4, divided by standard deviation, which we knew was 2. So mean and standard deviation are not changing in this problem. They're always going to stay the same no matter what your x or your data point is. So this gave me 0.25. Same thing over here. Plug in whatever my x is, minus your mean, divided by standard deviation. This gave me negative 0.7. Same thing down here. Plug in 3, your mean, your standard deviation, and that gives you negative 0.5. Over here, plug in your x, minus your mean, divided by standard deviation, and that gave me negative 1.625. Now notice, this number was a positive number, and my x was bigger than my mean. But all down here, I got negative answers, or negative z-scores, and these numbers were smaller than my mean. So that means numbers that are below the mean have a negative z-score. Numbers that are above the mean, that are bigger than this mean, have a positive z-score. Let's do a little more practice on z-scores and normal curves. So it says that Amy scored a 31. Okay, that looks like it's going to be my data point, or my x, or my element. on the mathematics portion of her ACT. The mean, that's one of my key words, that's the U, or the M, was 21. And the standard deviation, another one of my key words, that's the circle with a line over it, was 5. All right, so let's put this information here. So in the middle is my mean, which we know was 21. And we know we need to add whatever our standard deviation is, which in this case is 5. So plus 5 gives me 26, plus 5 gives me 31, plus 5 gives me 36. Over here, we're subtracting. So I'm going to minus 5, which gives me 16, minus 5, which is going to give me 11, minus 5 again, which is going to give me 6. They're saying her score was 31, which is right here, right on this 2 standard deviation mark. Now let's move on to Geronimo. So it says Geronimo scored a 720. That looks like it's going to be my X. On the mathematics portion of his 2009 SAT, the mean, that's one of my key words, and that's my U. Score that year was 515. And the standard deviation, there's one of my keywords, which is the circle with the line on it, is 95. All right, so let's put that information down here. So again, mean is in the middle, so that was 515. And then I need to add and subtract my standard deviation, which was 95. So this gave me 610. If I add 95, then I'm going to add 95 and I get 705. Then I'm going to add 95 and I get 800. Here on this side, I'm going to subtract 95 and I get 420. Then I'm going to subtract 95 and I'm going to get 325. Then I subtract 95 again and get 230. And it says his score was 720, which would be right here, right above the 705 mark. And the question says, use this information above to create a normal curve for both the SAT and ACT. Okay, we did that. So then it says whose achievement was higher on the mathematics portion. So Amy's was at the 2 mark, and Geronimo's was at the 2 and a little bit over mark. So I think it's Geronimo. But let's find our z-scores to figure out who did it. So we're going to subtract. We're going to do our score minus the mean divided by the standard deviation, which gives us 2. So again, the score, which was 720, minus the mean, which is 515, divided by standard deviation, which is 95. That's going to give us our z-score. And from that, we get 2.16. So this number is bigger than this number. So yes, Geronimo had the highest achievement on the mathematics portion. So that is how we use this z-score formula to talk about different types of data.